Hello everyone. Very good morning and good evening to all. Let us start our today's session. So welcome to Oracle SQL and PLSQL sessions. First, we are going to complete all the SQL. So for 3 weekends, and we will start with PLSQL. For the PLSQL, these SQL concepts are basic. So if you are having good knowledge on SQL, then learning PLSQL is very, very easy. So these SQL only we are going to learn, but procedurally we are going to learn. That's a difference. Okay. So first of all, what is database? So today I will start question they will be asking in interview also. Sometimes you are going for with very basic of database, and these any interviews questions they are asking what is data model. They'll be asking what is ER model, a normalization process, and different data types. So all this they will be asking the questions, different versions, all this. So we will see that theoretically all this. Then we'll go with the practical one. So what is data and what is database? So before 1970s, so in order to store, so you can take any companies, okay, any organization or any small organization or medium scale organization or any organization, if they want to store the data, they used to store the data like in some register, ledger, right? Notes. This is what they used to store the data. So after that, they used to store the data in the Excel or book. So if you take if I want to store my customers' data, okay, if I have my customers' data, my employees' data, so all this data, so I do have different products. Then, so I can have in the sheet, I can have it here. Okay, so each customer, I'll have the customer data. Yes, I will store all my customers' data here. So for what are the details you will collect from your customer? So I will collect the customer name, right? Yes, I will collect the customer name and then their date of birth. So even name also, you can go for 2 columns, right? So first name and last name. Yes, you'll go for first name and last name. You will collect, and you will collect. So what is the gender? Gender of the customer. And then I'll go for email ID. Then you'll go for phone number. Yes, you'll go for phone number. Then whatever the details you want to collect from the customers, you will collect it, right? Okay, I want to go for date of birth. Then address. So even address also, like address line number 1, line number 2, all this you will collect. And which city they are from, and country, marital status. A lot of informations you might be collecting from the customers, right? See, these details I want to store. Okay, I can store it in the Excel workbook. Yes, you can keep this way, right? So for each and every customers, you can keep it. But how do I uniquely identify the customer, this particular customer? Then I will have the customer. For each and every customer, I will give the customer ID. So this is what I used to have the data in before 1970s. For an example, this sheet, I'm having it for customer to store all my customer data. Yes, I will have all my customer data in this particular sheet. Then I will go for, okay, one more. I want to store my products. I do have different products. Yes, I can go for products here. Then I can go for, okay, so this particular store I have. So different store I have. Yes, I will have all my store details in the store table. So I want to know that, okay, so so store wise, how the transaction is happening. So just I want to analyze it. I'll go for store details. The same way I'll go for a lot of different tables, right? Say employees details. Yes, I'll go for location wise. So location. So how many locations I have my business. So this way I used to have multiple books in the single workbook. I'll have the multiple sheet. So if I have the data, So all this data, so I can store up to some 50,000 records or 1 lakh records. So we used to have this data in this format. So data volume, okay, my business has grown up and data volume also growing up. Then I couldn't able to relate these data, right? Okay, so for an example, I want to give some rewards for my employees. So those who have did so many transactions or the sales for our company, I want to give some rewards. So in order to identify the employee wise sales or employee wise the sales value, I need to do joins. Okay, I want to join this table, okay, employee table with sales table, right? So I want to make the joins from here to here, some other table. So it is very difficult to join a table and then get the details in a one single values. So to avoid this kind of the relationship of all the tables, they have come up with solution called MS Access. From Microsoft Excel, they have come up with MS Access. Then MS Access also is limited to some data volume. Then after that, 1970s, they have come up with database management system. And during 1970s, they have come up with DBMS, database management system. So what is DBMS? Say for an example, these are all data. So these are all data. So I want to store the data in, these are all like a structured data. So what is structured data? Say for an example, customer ID. Yes, each customer I can give some numbers, right? This customer number, this is my first customer. So each and every customer, I will give the unique numbers, correct? I will go for the serial of numbers. So each and every customer, I will give some unique numbers. Then customer name. So I can have the name and I can have the last name and gender. So email, these are all my datas, right? These are all my datas. So if I want to store the data in one place, that is called database. Okay. So you'll have the database here. In this particular database, I will store it. So I will store the data in this particular database. So this is called a database. So database is nothing but the place where we will store all the data, database. So this is our data. So here I have the data, right? These are all my data. Then what is mean by database management system? Then here I have come up with the DBMS, database management system. It's nothing but we do have a lot of, it is a software applications. Okay, so you'll be having this RDBMS, okay, relational database management system and DBMS. We have the DBMS here, will be running. This DBMS handles all the data in the database management system. So you'll be having this, yes, you'll be having Oracle, you'll be having MySQL or MS SQL Server. So different databases we have in the market. We do have many database management systems are available. So these database management system, it is used to store the data in the databases. So we do have a lot of concepts are available in the database. So that we will take it later. So to handle this database, we have the database administrator, DBA. So in the real-time project, we do have the database administrator. They will handle all the users, space, access and privileges, performance, migration. They will take all the database administrator. So we are the developers. Okay, we'll be writing the SQL queries to store the data in this particular database. Yes, whatever the data here we have, right? So these data, so all the data we are going to store as a table. As a tables, we are going to store in this particular database management system. Here I have one table. Here I have another table. Here I have another table. So this way I can have multiple tables. Multiple tables. Each and every tables is related with other tables. Okay, customer table. It's related with location. Okay, these customers are from these locations. This particular customer did this particular order, right? this particular location, these stores are available. So like this, multiple tables are connected with each other. So this database management system, we will call it as RDBMS, Relational Database Management System. So if you take database, is nothing but it is an organized collection of structured information. So what is structured information? For an example, if I have the data in this way, customer ID, yes, I will have only ID column. So here it is structured. First name, I will have name of the particular customer. Last name, yes, last name of the customer. Gender, so I will have male and female and others. That's it. Only 3 genders I will have. And I will have email ID. So it will have some format. Yes, phone numbers, some format, date of birth, yes. I will have some format, right? So these are all the structured database. Structured data. So these data, I can have it like structured. Okay, yes. You'll have this format only. Then I will have the address. Yes, you'll have the address, some city. Yes, here city we will make and country. Yes, I will make this way, right? So this is the way I will have the structured data in the rows and columns. This is one particular row, or we will call it as record. It's called record or row. It is called column, right? So we'll have the one column. So the column will have the particular data, the customer ID. This column will have only customer ID. This column will have only first name. This column will have only last name. So we can go for some relationship. Yes. So instead of having all the city here, okay, so we can have the city and country in another table. We can provide the relationship here. So that we will say the normalization process. But this is what we will store the data in the database management system, right? If you see this, so structured information or data typically stored electronically in a computer system. A database is usually controlled by a DBMS. Okay, so DBMS is an application associated with them or referred to as a database system. And this is what the database. If you look at this particular picture, you can able to understand what is DBMS. So this is what the database is used to store all our different objects. So I will tell you what is the objects. Okay, so different objects in the sense we may have the tables, we may have the views, synonyms, like different users. So indexes. So all this will have sequences, all this will have. So different objects we can store in the database that we will cover later. So database, then it will be connected to a web server. So this web server will be connecting to the database management system. You can have Oracle or MySQL or Teradata or MS SQL Server, all this. So in order to communicate with this DBMS, I need to know the language. Okay. So can I speak with the database with my English language? No. This database cannot understand our English language or any other language. So it knows only the SQLs. So that universal language we have to learn. So in order to communicate with the databases, we need to know the language called SQL. It is nothing but structured query language. So through this SQL, so we can connect with the different applications. So through APIs, so application programming interface. So through API, you can connect with the different applications, ERP, enterprise resource planning, web applications, dynamic websites, and software applications. So we are the user. Say for an example, you are going to a particular site and you are buying a product. So whatever you are registering in this particular site, you are very new to the site, but you are registering into the site. So what you will register? You will register with your name, email ID, user ID, and password. All these details you will be submitting your details, right? So if you are clicking on the submit button, so it will transfer, the front end application will transfer the data. It converts this data into SQL insert statement, and this DBMS will go and execute the statement in the database, and it will store the data in terms of database, in terms of this way. Okay, this way the data will get stored in the database. Okay, so whenever this is our customer details, right? So it will have another table called user details. So user, yes, have the username, right? So it will have the username and password. It will be stored in one particular database, one particular table. So this particular table will be very secured and they'll be using it. So whatever the username and password you have given in the very first time, so all the data will get stored here, and very first time it will authenticate. So once it has been authenticated, then this particular DBMS will allow you to store the data in the front end. So it will show you, okay, hello, your name will be displayed and all the details, whatever you have purchased previously, all the details will be appearing here. So it will connect with the database and it will pull the data based on your user ID, and it will show you the details here, your history and everything. So here the only thing is your user ID is the unique ID. It will be maintained based on the user ID. All these transactions will be maintained. So user ID will be connected to a customer ID. Customer ID will be connected to different tables and orders and everything. So it will be pulled from the database only. So that is what the data will be maintained in the database. And these data are called as relational database management system. So this is what the RDBMS structure. So in order to speak with databases, you need to know the language called SQL, right? So that SQL we have to learn. Okay, so you may ask questions. So what is the difference between DBMS and RDBMS? So DBMS stands for Database Management System, where RDBMS stands for Relational Database Management System. So if you take DBMS, the data are stored as a file. So you can have the XML file, JSON file. So these are all the DBMS system. Okay, so relating this file into another file is very difficult in DBMS, right? So instead, these data are stored in the tables, then relationship very easy. So that is what the RDBMS stands for. So RDBMS data is stored in the form of tables, like all the data are structured way. So we do have a lot of RDBMS available in our real-time project. So if you see this RDBMS, so of top 10 databases, if you take, so most widely used databases, if you take Oracle is the most widely used database. And we have MS SQL, sorry, and we have MySQL. So MySQL is open source database management system. And we have Microsoft SQL Server and PostgreSQL, MongoDB. So this way we have a lot of other databases. So we have Teradata, we have DB2, we have Netisa. So a lot of other databases are there. If you learn any one of the SQL very clearly, then working with other DBs are very, very easy. Okay, sometimes if I'm going with some interview, if I ask some questions, okay, which database you are comfortable, I ask, then they will say like, I'm comfortable with SQL. So SQL is not a database. So remember, SQL is not a database. SQL is a language. In order to interact with these databases, we need to know the language called SQL. That is different. But if I ask which database you are comfortable, you have to say any one of the database. So here we can have the database like Oracle, right? Yes, MySQL. So is that if you ask, so MySQL database and Oracle database, is that same SQL will be used? No, slight differences will be there. So that differences we can learn quickly. 90% of the SQL queries are same. Only 10% SQL keywords are different. So that we will learn quickly. Okay, no issues. And if you take, so what is this data model? So why the data model is needed for each and every companies, right? For an example, you assume that I want to start a grocery selling app. Okay, so you want to develop a company so that we are going to sell some groceries. So if I want to build this particular mobile app, okay, So first we have to do the data model in the backend. So front end, yes, they will use the website and they will create a login. And so once you have logged in, they will go inside. It will be showing all the details. So based on your products, you will be choosing that and you'll be adding into the cart, and you are going to the cart and then you are doing the checkout and you are giving the address and you'll be doing the payment and you are completing the transactions. So this is front end. The front end developers like a .NET or the API developers, they will be doing all this kind of activities. But what about data? Okay, so you will be showing some data, right? So you have 10 products, 9 products has been blocked. So you'll be having one more product only. So that you have to show, or you have to show them like it's out of stock. So these data will be collected from the database. So in order to have this grocery selling, so you need to have a first data model. You have to create it. Okay, so how can I create the data model? First, we'll go for conceptual model. So what is conceptual model? So first we will take one pen and paper, then we will design it. Okay, so I need to have these products. Yes. So I do have these stores. I have some 3 to 5 stores in my locations. So if they are from these particular, from the app, I will connect to the Google map. And from this particular location, I have to point it to them, this particular store. And I have to assign the delivery partner to deliver the product, right? So I'll be having product, store, sales, or time. Time will have this particular dimension table, will have all the date, time, all this. Then we'll have the delivery products. So different tables, locations, city, country, all the tables, I will have it. Whatever the details I need to have. Okay, my employee details, customer details. So all the details, whatever I have, I will collect it. I will go for the conceptual model. So in this model, in this particular stage, I do not want any software. I do not want any particular tools. So just you can collect all the informations, how the relationship we are going to have it. Okay. So here, whatever the tables we are going to refer, it is a called entity. So time entity, product one entity, store is another entity, employee is another entity, locations. So different entities we will have. Entity is nothing but a table. And we will have attributes. So attributes is nothing but inside the table, you will have attributes like, okay, you'll have one column. So these are all attributes. If you take this particular table, so these are all attributes. This is attributes. This is attributes of the particular customer, right? Yes, this is called customer entity. So how these entities are related with each other, right? So how the customer is related with the product. Okay, I'm the customer. I'm going to buy a particular product. Okay, this particular customer purchased this particular product from this particular store. This particular employee helped in this particular location. See, these are called related object, right? So how these tables are related with each other is called entity relationship. Okay, that is called entity relationship model, ER model. So the same way, this is also one of the ER model we will have. So in this particular conceptual model, we will not have no attributes is specified, no primary key is specified, just we will have only entities. Okay. Only entities visible, and it's highly abstract model. So it's high level model. So we'll not have any in-depth primary key and foreign key and all. So just we'll have the conceptual, no software tool is required to define the conceptual data model. Yes. Then after that, okay, next step, we have defined all the tables and everything. Then next step, we will go for each and every model, we'll have the, okay, so each and every table will have this the columns. Okay, so for product table, so which table I can have? So for customer table, what details I can collect from my customer? Yes, I need to have a data birth. We can send notifications or wishes to the customers on the birthday or I can have this data, but for security purpose as well, right? And phone number, email. Yes, you can send all your upcoming events and everything to the email ID. Yes, these details you can collect from your customers. So in addition to this, you can collect more information also from the customers, right? So all these details are entity. So whatever the details I want to collect, so that we will define here, the attributes. Yes, products, product descriptions, category, and category description, unit price, created, updated, all the details I will collect. Store details, sales details, time, customer, locations, delivery partner details, employee details. So in that way, I can collect all the informations in this model, particular model. Okay, how these tables are related, that is called entity relationship model. So here we will define the primary keys and foreign keys. In the product table, product ID is the primary key. Okay, so while coming to the sales table, in this particular store, this particular product, in this particular date, purchased, this many item has been sold. What is the total amount? So that details we will collect, right? So this particular table will have only the entries, foreign keys. No need to mention the store details again. Just to keep only the foreign keys. If I need the details, I will go to the table and I will get the details. Okay, which store? So in the sales table, I'll have only IDs. Whenever it requires, then I will go to the other table. This is called relationship. How these tables are related with each other. So that is what we will go for the logical model. In the logical model, you will define the primary key, foreign key relationship and column names, attributes, and everything. Okay, so for this, you will have some data modeling tool. So you'll have some data modeling tool called Erwin, or we'll have some Power Designer. Some tools are there. So in the logical design model, we will create all this. Then we'll go for the physical data model. This is the last model in the database modeling. So in this particular database model, so each and every table, we will define what is the data type and what is the length, maximum length we can go for. Okay. So in order to store my data in the memory very optimizely, you have to provide the data type as well as data length. No need to mention very big data length. It will store a lot of null spaces. To avoid that, we will go for we will define the data length very clearly. Okay, integer, decimal, varchar, date data type, float data type, all this we'll mention here. And by using the tool called Erwin, okay, so if you are going to execute this particular data model, so you have to select the database in this particular tool. So Erwin, we have Power Designer, we'll have. Just you select the database. And if you are going to enter like create tables, so with this relationship, it will go and create all the tables. So without any data, it will first create the model. Then we are going to the live. So live means production. So we are going to the live. So live data will be coming. So that means, so you are going to the live product. Today you are launching your product. So each and every customer will go and log into our site, and then they will be entering their details, and all the details will be converted into insert statement. And this insert statement will go and insert the data into the tables, right? So this is what it will get inserted. So these details will be collected from the customers, and this one we are generating it. So why do we need to generate this particular ID, right? So to identify each and every customer uniquely, we have to generate this particular customer ID. So that is what we will do in our real-time projects. So whatever the details we are collecting from our customer, so all the details from the front-end tool only. In the production database, we will never ever insert or update the data manually. So all this happening by the system only. So very rare scenario, manual intervention is needed. So other scenarios, all the details are coming from the system user. So how we are having the user, right? The same way, system will have the users. So from the system user, we will connect it. We will create the tables. Okay. So this is what the three different models in the database, we will collect it. Okay, so we have done with all this, right? And we need to store the data without duplicates. Okay, so without data redundancy, we have to have the data, we have to use the data, or we have to store the data optimally in the database. How can I do it? So for that, we need to know the normalization process. So what is normalization? See, normalization is nothing but the normalization is the process of eliminating the data redundancy. Redundancy means repeatness. So to avoid the data repeatness, we are going for the normalization and enhance the data integrity in the table. So what is data integrity? How these tables are related with each other. So that is what we will go for the normalization. Okay. So we cannot store the data. We cannot build a data model as it is. We need to follow some rules. So what are the rules? So sometimes if you are going for any interviews, they will ask this type of questions. So PLSQL developer, definitely they'll be asking these questions, right? So what is normalization? So normalization is the process of organizing the data in database to avoid data redundancy, insertion anomaly, update anomaly, or deletion anomaly. What is that? We will see one by one. Okay. See, if you take this particular table, so employee ID I have, an employee name, address we have, and department. For an example, this particular employee working in two departments, department 1, department 2. And this particular employee, same way, is working in two different departments. So what is that update anomaly? If I'm going to update the address, for an example, if I'm going to update the address of the John, okay, for this particular, we have to update the same row 2 times, right? If I'm going to update address of the particular employee, yes, we have to update 2 times. And here also 2 times, yes. If I'm going to insert, so one more time, if I'm going to have one more department, then you will have one more records. And delete also. If I'm going to delete the particular record, it will get deleted 2 records. Both will get deleted. If I want to delete this particular record, then I have to mention the department name. So this particular department, I'm going to delete it. If I have any other particular employees available on the same department, it will get deleted. Okay. So this is what some anomalies will happen. So to avoid that, we will go for normalization. Normalization is nothing but it's very simple. To avoid the data redundancy, we are going to split the table into multiple tables. Okay, so to avoid the data redundancy, we are going to split the tables into multiple tables. So if I'm going to keep all the data in one single table, so you'll have some duplicate, right? To avoid that, we'll go for different normal form. First one is first normal form, 1NF. Second normal form, third normal form, Poisson card, normal form. So this is BCNF, we will call it as. So what is that? We'll see one by one. Okay, sometimes they will ask in the interview. For an example, if you take first normal form, so this is first employee having employee name, address, and mobile number. And second employee is having two mobile numbers. So how can I store these details? Can I store this way in database? No, we cannot store this way in database. If I have two datas, I cannot store this data in this way in database, right? In Excel also we cannot store this way. So how can I store? I will have two records, right? So this way I will have. So this is called first normal form. So in the first normal form, I will have the duplicate records here, right? So 1 or 2, I have two duplicate records here. 2 times I'm going to store the same data. So two employees. So we'll have two mobile numbers. If I'm going to store them, so this is what the data I will store. Okay. So this table, the first normal form. Okay. But if I'm going to have So this is the way we will store like first normal form. Then the second normal form. That means in this particular first normal, we will apply some normalization process. The table should be there in the first normal form. The primary key of the table should compose only one column. So that is what the rules of the second normal form. Okay, if you take this particular table, here I have the two teacher ID and subject and teacher's age you have. So I have the teacher ID, maths and physics. Yes, she will be handling two subjects, maths and physics. And I will have the two records, right? And biology and physics. Biology is having one particular teacher, then physics and chemistry handled by one single teacher. So instead of having the data in this way, this is something like same data two times repeating. So I'm going to split this table into two tables. So that means, so teacher into different table, subject into another table. So teacher ID and teacher age, I'm going to have one single table. So I can avoid the duplicate, right? So if I'm going to have teacher ID and teacher's age, so I can avoid the duplicate here. Just I will maintain this way. Then teacher subject, yes, I will have this way. So again here I'm going to have some duplicate data. So in this particular teacher ID, right? Yes. Subject is okay, but if you look at this subject also I'm having duplicate. Teacher ID also I'm having duplicate still. But I can relate these two tables by using the teacher ID and I can get the teacher's age. So in that way, this is second normal form. Okay, still we have some duplicate, right? To avoid the duplicate, we'll go for the third normal form. So in this normal form, the table should be there in second normal. That means the previous condition should be satisfied and should not have any functional dependency. So if you take this particular table, so first we are storing all the details in one single table. Means employee ID, employee name, employee zip code. So their state, and employee city and district. If you take this particular details, right? So how we are going to split up? So all this we are going to split up into one table called employee table. And this is we are going to split up into employee zip code. So only one time I'm going to store here. Okay, only one time I'm going to store. So whenever required, I will maintain it here. So that is the way I can avoid the redundancy of this zip code multiple times here. So to explain this, I can go with, okay, so one more explanation. So for this, just a second. So if you take this particular table, so I have employee details, right? So if you take the first table, employees details, so all my employee IDs and their name, mobile number, address, date of birth, skill set, and everything I'm collecting from our employees and which location they are from. So which location they are going to work. So that particular details also I'm going to keep it here. So my employee details and their locations. See, you assume that I have only three different offices. Okay, three different offices. I have 1 lakh employees. So all the employees going to work on these locations only, three different locations only. So do I need to mention all the three different locations for all the 1 lakh employees multiple times here? No. So what I'm going to do it, this table I'm going to have only the employee details. Yes, I will have all the 1 lakh employee details here. The table I'm going to split up. Okay, like office address. So first one location, yes. This is for Chennai locations. So I'll have Chennai. Okay, this is for Bangalore. Yes, right, Bangalore. Then I will have, this is for Pune locations. So three different locations, three times I have mentioned here. If I'm going to have one more location, just I will make here office ID and then I'll keep it here. So then if the employees are joining this particular office, I'll maintain here in this table. So how many times I'm having the office details? Only one time, right? So instead of repeating the multiple times data on the same data, I'm going to have only one single time here. Whenever needed, I will repeat the details here. Okay, this particular employee from this particular office, this particular employee from this particular office. Yes, this office address might be repeated one. That's fine. Only one column I'm going to repeat it, right? For an example, how many of them are from Bangalore? If I want to know, then I will take Bangalore is nothing but 2. So I will get these 2 here and I will join it, right? So join this table, I will join it. Then I will get the details. Okay, 3 members are from Bangalore. That we can relate. This is called relationship, right? Entity relationship model. So to avoid the data redundancy, we are splitting the tables into 2 tables or more than 2 tables. That is called a normalization process. Okay. So third normal form, to avoid complete data redundancy, we'll go for third normal form. Clear? Okay. So this is what the BCNF model also will have this tables into multiple tables here. So same, instead of having all the details into single table, we are splitting the tables into employee nationality and employees departments and the employee departments mapping. That means we are how these 2 tables are related. So that we are bringing it into another model. So this model will call it as BCNF model. Okay. So if somebody asks, so this is what the relationship you can tell them. So most frequently used model is the third normal form. So in our real-time projects, if I'm going for any data model, we will use third normal form or BCNF model. Okay. So this is what we will store the data in the database management system. So I hope you are clear what is entity relationship model. So all these models. And so we do have, as I told, we do have different databases are there in the market. Okay, we have different databases. So what is databases? So you have Oracle is one of the database. It's RDBMS. Then we do have different databases like we have the Microsoft SQL Server. It is another database. Then we have the IBM. IBM, we have DB2 as well as Netisa. So we have Netisa, right? So this is also one of the database. Then we have the Teradata. Yes, we have the Teradata. Then we have MySQL, so open source database, and PostgreSQL. Yes, this is also one of the open source SQL. So different databases we have in the market. So you can go for even NoSQL DB and all the database management systems like PostgreSQL. Lot of other databases are there. Okay, so we can learn any other databases if you know one particular database very clearly. So if you know Oracle database very clearly, then working with other databases are very, very easy. So you can go for any other database like relational data store in Amazon we have. Yes. Then we have the different databases, right? Redshift we have like data lake environment. We have a lot of other databases are there. These databases is similar SQL will be used. You can go for Snowflake also. Yes, it's a cloud database environment. All these are using the same kind of SQLs, but little difference. So even if you are going for any cloud or no SQL DB, so we have no SQL, right? No SQL is nothing but not only SQL. So that is different concept. So if possible, I will take later. And no SQL we have and cloud SQL. So cloud means as we have the different cloud, we have AWS, AWS we have RDS, relational data store, and Redshift we have. And if you take GCP, we have some big queries, right? The Snowflake we have, all these are cloud we have. So in the cloud also we can store the data. But one advantage in the cloud, we can store structured, semi-structured and unstructured data. So that's what we will go for. Mostly we will go for this GCP GCP is nothing but Google Cloud Platform, and AWS and Azure SQL. You heard about this Azure SQL also, right? So definitely these SQLs are stored structured, semi-structured, unstructured data also. So for most of them is for AI and ML process. So ML is nothing but AI is nothing but artificial intelligence, and ML is nothing but machine learning algorithms. So like if you take YouTube or Netflix or Amazon or any other site, right? So they'll be collecting the user data, they'll be processing it. After processing, they are again feeding back to the same to the database, the front end for the better user experiences. They'll be giving some recommendations. All this they will be providing, right? So that's what it will go for the AI and ML process. So that is data processing. It is a different way of storing the data. So for any databases, if you're going to use, if I want to interact with these database, I need to know the language. So can I use SQL language? Sorry, can I use English language to communicate with this database? No, I cannot use English language. Then which language I have to use? I have to learn this like language, their language. So that language is called SQL, structured query language. This language we need to learn to interact with these databases. Clear? So each and every SQLs will be unique and slightly it will be vary. And if you know Oracle SQL and DB2 is similar, and here if you take Snowflake is similar. These three are similar SQL. And if you take SQL Server and Teradata is similar, okay, and MySQL and PostgreSQL, these are all similar. So most probably this is what we will use. And yeah, if you know one SQL, other SQL is very, very easy. Okay, I got one questions. Can you explain the third normal form? The third normal form is nothing but if you see this third normal form, right? So if you take this particular table, so how can I improve the data redundancy? So that means, see, you have your employee, you assume that you have 1 lakh employees here. So you have business only in these particular state, at least 1, 2, 3, 4, 5. 5 states only you are going to have employees. So only 5 states only are going to have the employees, right? But if I have 1 lakh employees, how many times you will be repeating this details? Employee state, city, and employee district. How many times you are going to repeat these 4 columns for all the employees? Multiple times you have to repeat, right? So you have only 5 different locations, but you are going to have 1 lakh employees. You are going to repeat these details 1 lakh times to avoid this kind of redundancy, this kind of data redundancy. Here I do not have any redundant data, right? Here I do not have any redundant data, but I will have it. So you may have same locations, you may have one more employee details, right? So that means you are repeating the same data multiple times here. Assume that 10,000 employees from this particular location. So this employee details different, but these 4 details are repeating, right? Multiple times. To avoid that, we will split up this table into 2. We can have all the employee details here and their location alone, the zip code alone, I will make it here. Then if I need, okay, in this particular zip code, how many employees are there, then I have to take this particular table. This particular table, I have to join it, I have to get. So this is what I will have this to avoid the data redundancy. So data integrity is nothing but so how these tables are related with each other and how we are reducing the redundant data. So that's what the data integrity. So I hope you are clear. So we do have a lot of other databases. Among all the databases, Oracle database is widely used to database in the real-time projects. So mostly like OLTP system and OLAP system, still most of the companies, they are using Oracle as the data warehouse also. they're going for. Okay. So this is what the database. We do have different versions. So if you take Oracle alone, in this particular training, we are going to take Oracle only. So Oracle database only. So if you take Oracle database, so we do have different versions. We have started with 8i or 8i, then we have 9i. Okay, so how we have the mobile versions, right? So iPhone versions we have. So functionality wise, all the phone wise, everything is same. But the features they have added. Okay, so previously we have 5 MB megapixel camera. Now they have 8 MB, 16 MB. They are increasing the 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 features. Okay. The same way here also. We have 8i, 9i, then we have 10G. Okay. So 10G, 11G, then 12C, 12C, 18C, and 19C, then latest version is 21C. So if you take this I stands for internet. Okay, I stands for internet. So that particular time during 1970s or 1990s, the internet came into picture. That time they have started this particular version 8i, 9i. Then they went for grid computing. So they do have the grid computing for so 10G and 11G. So after that, they have come up with in 2012, they have come up with 2014. They have come up with this particular 12C versions. So C is nothing but cloud computing. So now we have so all the four versions. So after 2014, they have come up with next version 2018. So that's what 18C, 19C. Now we have the latest version 21C. So year of 2021, they have released. So this particular versions. So most of the real-time environment, they are using this particular versions. So I have given one document to define all the versions. Okay. So different versions of Oracle here. So it's nothing but, so I hope you are, so 2001, they have starting with 1990, they have started with the 8i. Okay, so they have introduced with so JVM. JVM is nothing but Java Virtual Machine. Then they have after that they went for grid computing. So grid computing for so how the computing engines is okay. So clusters they will have different clusters. It is used to do the computing. So different clusters. After that they have come up with cloud computing. So now we have the cloud computing versions. So I have given some differences between the 11G and 12C and 18C. So when they have implemented 18C and 19C and 21C. So now we have the versions. So this is what the 21C. So 21C is the latest innovation release. So they do have different tables. Okay, so like we have the blockchain tables, so immutable tables, machine learning algorithm, and SQL macros and JavaScript executions. So all this we have explained, plan cursors, all this we can compare it. So this is what the new first features they available. So if in your organization they have the 12C or 18C or 19C, they can directly migrate to 21C versions. So it went for Oracle Cloud as well as on-premises server in the Linux environment. Okay, Linux or Unix environment. On top of Linux or Linux, they will mount the server, and so this will handle all the data for our company. So blockchain tables and immutable tables is nothing but so it is used to insert the data. So we cannot delete the data. So at any cost, you cannot delete the data. So you cannot update the data also. So you cannot modify it. So immutable table is nothing but only insert. You cannot modify also. So deleting rows and modifying rows is completely prohibited in this particular immutable tables. So I have given some features between 19C and 21C. What is the differences? So first I will take the database. Then later, while completing our SQL, I will show you this differences. That time you will come to know. So how this differences are there. Okay. So grid computing means yes, we have some clusters, right? We'll have this different servers. So this is particular. You'll have the clusters, and this is another clusters. These are all one grid. So these are all another grid. So many servers are running. Okay, so you'll have different nodes. So inside you'll have some different nodes, right? So you'll have one node here, one node here. So whichever node is free, so it will go and do all the computation first. Okay, so like this, it will do the grid computing. So whatever the database we have, so a lot of different nodes will be there. So even one node is failure, it will not. So all this, whatever it handles, it will give it to the other nodes. So this will take care all this database activities. Okay, so this is one grid, another grid. This is nothing but clusters of the computers. Okay, it will do all the, so different, these are all one servers. Okay, so I will give you one document here. So if you go to the 21C architecture, so this is from Oracle Corporation only. So you can just, if you have time, just to go through this, how this data will be stored. So how the data will be processed. So client applications, this is what we will write the SQL queries we are going to give here. And listener will take that queries and it will connect to the server and it will access the data files and system files. So the data will be stored as the file only in the inside the database. So it will store data like this only, but we can see the data in terms of tables and views. So that's what we will have. So whenever you have some time, just to go through this particular document, you will get a clear idea. So how the database will store all the data. Okay. So we are not going to much into the database architecture. Why? Because so whenever you are going for any DBS, then we need to have a architecture wise. Okay. So this is what. And so if you have already installed, any one of the version, okay, if you have already installed 11G, so keep it 11G, no issues. So if you have already installed 18C, keep it 21C, just keep it as it is. No need to change this particular versions. Okay, so we can have the same versions. We can work on this particular versions. We can query it. If you haven't installed, I will tell you how to install it. Okay. So do you need installation session to install the software, or you have already installed? Most of them installed. I hope most of them installed. So any versions we have installed, no issues. Okay. So 11G, 18C, 21C, any one version is enough. Okay. So if you have installed 11G, that's fine. So we can have it like 11G. Okay. You may ask, latest version of Oracle is Oracle 21C. So if you want, you can install 21C also, no issues. But if you want to install Informatica Power Center, okay. So in your system, if you have Informatica Power Center, then have only 11G. So Informatica Power Center, if you have, so have it like only 11G. So don't go for 21C. 21C sometimes it will not be supported by Informatica Power Center. Okay. But installation, I will tell you, no worries. So how to do it? Okay. So if you ask what is database, as I told, database is nothing but, so it is used to store the data, right? So if you take, this is one of the data, and so if you have IICS, you can have any versions, 21C or 11G or anything. Okay. So I will tell you that installation process, no issues. Then what is database, first of all? If you take, this is the database. Okay. It is used to store the data. So you can take it like Oracle 21C. Is the database. So inside the database, some spaces will be reserved. Okay, this particular space will be reserved. So you cannot use it. So this is called system space. Okay, system space. So it will hold all the metadata informations. So what is it, right? So you'll have the system user. So you'll have the system user is nothing but admin user. So the DBA will handle it all this in real time project. If you are going with DBS nothing but database administrator. They will have access to these particular informations. So what is it? See, if you have the if you are going to store the data here, I need to have a master data, right? Okay, where the data is present. So who is storing the data? How many records are there in the table? When it has been modified. So all the information I need to store in another tables in order to maintain the data integrity. The primary key, foreign key, all the relationship when the user has been created. So all this I need to maintain it into some tables. So that tables will call it as metadata tables. Okay. So metadata. So metadata tables, I will store it in this particular schema. Okay. This particular area. So this user, we will call it as system users. So metadata tables. So what is that? So we will call it as dictionary tables. So I will tell you what is the dictionary tables. So all the dictionary tables you should have idea. So this dictionary tables. So I will give you some list of dictionary tables so you can have it. So those tables will be maintained by Oracle database itself. We are not going to maintain any of the dictionary tables. So all the dictionary tables will be maintained by Oracle itself. So whenever you are going to create a table here, or whenever you are going to create a schema, or whenever you are going to create a user, all this will be maintained by the system in the dictionary tables. Yes, we will have. So for an example, if you take this particular system, the system users, so mostly you'll have the username will be system. What about the system, right? Or we have sys user. Yes, username will have sys. So that is what we'll have. Then we'll have the password. So we'll be having a password. So password is nothing but. So whatever the password you're going to give while installing the software, remember this password. So username will be your system or sys user. So you can go to the any users and then you can connect with the, then this is the password. So you can have here, and by using this password, you'll be connecting. Okay. So this is what you'll be. So using the password. So by using this password, you'll be connecting to this particular user. Yes, you can connect. So after that, in Oracle database, you can have multiple users, and we will call it as it's a user schema. So whenever you're going to create a user in Oracle database, schema will be created. So you can create multiple schema. So schema is nothing but logically grouped objects. That's it. Okay. So if you take schema is nothing but so logically grouped object. So I will give you one particular document. So just to go through this particular document for schema also. So schema that allows you to logically group objects in the Oracle database. Okay, you can create a schema. Schema is nothing but schema is created in Oracle when user is created. So whenever you are going to create a user, a schema will be created. So you can create by using this particular statement, create user, username, identified password, and table space, and temporary space, and particular code. Sometimes it is showing like it is you are exceeding that quota, right? So you can extend this quota by using this particular statement. So you can provide access, privileges, and everything. But if you're the super user access is DBA. So if you are going to give DB access, so all other permission will be granted. So no need to mention this particular statement, just you can mention the DBA, then it will have all the access. So whenever you are going to create a schema, so this is what the user schema. So this particular schema will be created. So if you take 21C, 21C is nothing but a pluggable DB. So in the pluggable DB, you will not have your any schema. Just it will come up with only the system schema. System schema alone, you'll be having it. So other schema will not be available. The thing is, you have to import the schema called HR. So you can import it. Yes, you can import the HR schema and you can import any other schema. Okay, you can create any other schema. HR schema means what is schema? It's a different object. So what is a different object? If you call it as different object. So the object might be a table. Yes, you can have a table and you can have a views, right? Views, and we can have the sequences. So you can have so different objects. Okay, you have the sequences. We can have the indexes. Okay, so index and synonym, right? So this way you can have different objects. See, all these objects are, you can have it in the particular database. So this might be a table and this might be objects, users. So different tables and views. So everything will be there in the one particular schema. So this might be a table, this might be a views, this might be a sequence, indexes, all this you will have. So this logical group, we will call it as one particular schema. So this is one particular schema. Yes, this is one particular schema. So schema is nothing but, okay, so we are going to some mobile shop. You assume that we are going to a mobile shop. They're having all the mobiles, all the brands they used to have. So iPhone they have, then they have the Samsung, they have the Nokia, different mobiles they have. So if they are keeping all the mobiles in one single place, how do you feel? Or how they will take it and how they will arrange it? And they are going to have all these different brands in different racks, okay, different places. They're going to have Apple in different racks, Samsung in different racks, and Nokia in different racks, right? And different, and even in the inside of Samsung also, they can have multiple different models, right? They're going to arrange it the same way. So each and every schema is nothing but logically grouped elements. So in this particular objects, you can have a tables, views, and sequences, indexes, and synonyms, everything. And you can have it different objects here. Yes, different tables. So you can have the different tables here and different sequences, different indexes, views, and everything. So you may ask questions. So here I have the table called employees. Employees. Can I create employees table here? Yes, you can create, no issues. With the different structure, with the different columns, no issues. Can I have the employees table? Yes, you can have. So this employees table can have different data. This employees can have different data. But if I want to access this particular employee in this particular database, you have employees table in two different schema? Yes. Then how can I access it? So how can I call this particular employee? So you have to tell this HR schema, HR dot employees, core dot employees. If you are referring HR dot employees, this particular table, it will be listing, it will be showing you. If you are defining that core dot employees, this particular table, it will show you. So this is what you can have the different tables, different objects in the schema. So how many schemas are there in this particular database? So now, as of now, we have admin schema, HR schema, and core schema. How many schemas I can create? You can create a number of schema in the real-time projects. So who will create all the schema? Only the DBS will create schema. So the system user is a super user. It can access any other schema tables. So it can access any other schema tables. It will have all the access. But as a HR schema, can I able to access core schema tables from here? No, you cannot access it. You will not have access. If you want access, you have to request DBA, hi DBA, I want to access the score schema tables. Can you give me the access? Then they will ask approval. Okay, these tables are very sensitive tables. In order to access these tables, you need to have these particular roles and go and get the roles. Then you have to connect with the system users and you have to get the roles. Then they will be providing you the access. So this is what in real time we will have it. Okay. So with this database, can I access it? How can I interact? How the tables are related? So how many tables are there? All this, how can I do it? So we do have different front-end tools. Okay, we do have different front-end tools. We are the SQL developer, right? Different tools we can have. SQL developer we can have. So we can have the SQL plus. So we can have the DB visualizer. So different tools are there. So we do have different tools. So a lot of SQL plus we have. Okay, so different tools are there. By using any tools, so any one tools, you can connect with the database. So you have SQL developer. Yes. So you can have the code for Oracle. Yes, you can connect with. So you have the SQL plus. SQL plus, yes, you can have it. So here we have the DB visualizer. It's another tool. Okay. So you can have this DB visualizer, you can connect with. So whatever the front end tool you are connecting, okay, so all the front end tool will show you the same data. So in this particular table, in this particular SQL developer, you are going to execute one particular statement. So what is the statement you are going to execute? Select star from the HR.employees. It will show you the same data here also, here also, here also. So these are all the GUI, graphical user interface. So it will show you the data like in a very good visualization. The SQL developer will show you the data in the form of tables, rows and columns very clearly. But any one of the tools, you can use it in your real-time project. No issues. All the visualization tools will show you the same data only. So this is what the connections. So you remember we will connect from the SQL developer, right? This is what the connections. See, in the real-time project, this will be there in one particular location. You assume that this is there in the USA. But as a user, as a SQL developer, we are in India. You assume that, okay? Then can I connect with this database? Yes. So one particular user in India, one particular user in USA, one particular user in UK, any different locations, you'll be creating a connections by using that node, port, and all the details, right? So whatever the details you are going to connect in the network, it will be connected and you'll be connecting through this particular front-end tool and you are able to access this particular database. It depends on the project need, space, and they will create more number of space. Storage team, they will have some separate team will be there, storage team. If the admin is not finding the storage, they will create a storage and then they will add the storage and then they will create multiple schemas based on the project need. Okay, so I hope you are clear how this structure will be used and how these tables are used. So what is dictionary tables? So before going to show you the dictionary tables, so how can we find schema in a table? Yeah, I will tell you how to find multiple schemas are there. Okay. So that I will show you the dictionary table concept. So how many tables are there? How many users are there? So that we can find it. But in real-time project, we cannot find how many schemas are there. Okay, so that access only the DBA will have it. So what is the default table space? Yes, you will have some table space here. Okay, default table space, all this. The DBA will take care. We are not going to do anything. It depends on the project, the database size. So they will give you, but we are not going to take care of all this space and everything. As a developer, the logical division of the different objects are called a schema. So we do have huge volume of data in real-time project, right? So we cannot store all the data in one particular schema. So based on the particular application, based on the particular project, we will split up the database into multiple schemas. So HR schema is one schema, core schema is another schema. It is what I will have. So who will be the super user? Super user is system. By using system, you can able to access any other schema tables. This table you can access, this schema tables you can access from the system user. But if I am the if I am the HR user, can I access any other schema tables? That's what I have explained, right? If you are the HR schema user, you have access to this particular HR schema only. Then you will not able to access other schema tables. If you want to access these schema tables or views or anything, you have to request DBA to provide the access. Okay, I need to have the access. So from HR, I need to access the core schema tables. So that privileges your admin should provide. If they are providing the access, then you can able to access the other schema tables. In one particular, see, if you take Oracle database, whenever you are creating a user, okay, for an example, HR user or core user or any other user, so that will create a user schema. HR, human resource, is one schema, core is another schema, retail is another schema, different schema you can create it. So inside the schema, you can have other users. So other users, nothing but by using that username and password, you can able to access this HR schema. Okay, so I will show you that. So who will make the changes? Other users. The DBA only will make changes. We are not going to do any changes here. If you have access to the HR schema, you can able to see only HR schema objects. So what is objects? Tables, views, sequences, synonyms, indexes, different objects are available. Okay. So these are all SQL objects. We have PLSQL objects like procedure and functions and triggers, packages are there. PLSQL objects. So core schema. Yes, you can able to access other schema tables, but provided you have to have a particular access from the DBA. Clear? So what are all the dictionary tables? Whenever I'm going to create if you take Oracle, it is a schema. If you take SQL Server, see, this is one particular database. SQL Server, one particular database. You can split the database into multiple databases. So this is DB, one particular RDBMS. Inside the DB, you'll have multiple databases. So this is one DB, HR DB, and then you have another DB here, right? You have another DB, retail DB. You have the sales DB. Yes, you can have different DBs here. So multiple DBs. So you can keep it. So instead of schema, we will call it as DBs here. So in SQL Server, in Teradata, so all these databases, we will call it as DB. So yes, schema is nothing but a logically grouped object. Okay. So I hope you are clear now. HR schema user can able to update or only can view the data. Yeah, so that privileges, that's what the privileges. So if you will have different environments in the real-time project, right? So you'll have different environments. You have the development environment. If you are going to work on development environment, so that is called a dev. So in development environment, you will have all the privileges, right? So you'll have the read access, write access. Write means you can able to update. Okay. So execute access also. So you can have the execute access. You can run the jobs or anything. Read, write, execute options you will have. But if it is in production, you will have only read access. You can able to query the database. That's it. You will not have any other access. It depends on the environment, which environment you are going to work on. If it is a live production environment, you will not have access. So some prod DBs, Even you will not have read access. So that is the sensitivity of the data and tables. It's a depends. But you assume that this is development environment, you will have all the access. But still, since you have access only to the HR schema, you can able to view only HR schema tables. Other schema tables you are going to access it, you will get error like you do not have the correct privileges to access these tables. That's what you will get it. Clear? So if you see this in our system, I have already installed Oracle database. I will give you, if you haven't installed database, I will give you the installation step. So after this base session over, in the mail, I will send you how to install Oracle 11G in your system, Oracle 12C in your system. So you can select it whichever the database you want. And this is the database which I have already installed in my database. Since I have Informatica and IECS, all the softwares, I have installed 11G. It's fine, no issues. You can have it 11G itself. So all the SQL queries will be supported here also, right? So here we have the 11G. So this is database. But directly I cannot, if you double click on this, it will open this particular page only. So I cannot go and directly query this particular database, right? This one I cannot directly go into this and I can access it. See, in order to query this particular database, I need to have another tool called SQL Developer. Even you can have one thing called SQL Plus. So you can connect with SQL Plus. You can open it. See here, it is showing like Oracle 11G, right? So 11.2. So this is what it will show you. So this is the one. And it is asking you to enter the username. Which user you want to connect it? You want to connect HR schema, right? You want to connect with the core schema. You want to connect with admin schema. The admin schema is the super user. Yes, I want to connect with admin schema. The username is system. Then password is whatever the password I have given while installing. That's admin password I should have given. I'll be connecting. It is showing like, so it has connected with Oracle 11G Express Edition. So we do have different edition I will show you and different number of bits you will have. So as of now, we'll have only 32 bits. So all the systems will support only 32-bit editions, all the system will support only 64-bit editions, not 32-bit editions. Okay, remember this. So this is the schema and everything. I hope you are clear. And we do have different editions. So if you go to this one, this is called Express Edition. So Express Edition is a light weight and it is for academic purpose you'll have. Then you'll have the Standard Edition. Standard Edition will have the licenses and you will have the Enterprise Edition. So Enterprise Edition only in real-time project, they will use it. So we will not have this Enterprise Edition. So why? Because you need to pay the license cost. So in the real-time project, we will have the Enterprise Edition, but the SQL queries are same. The SQL queries are same. We will have only Express Edition. That is what we'll have. XE, Express Edition. Some editions will have ORCL. That is different. Okay. Standard Edition, Enterprise Edition. Standard Edition means yes, all the editions will have the same SQL statement, but depends on the license will have access. Okay. So here we are going to have Express Edition. Okay, XE, Express Edition. That's what we'll connect with. Service ID is XE. So with that, you can have all the schemas, users, and everything. You can have it. So this is what we have, the 3 different editions. So I will save this and I will give it to you after this particular one. So okay, so this is what I will be connecting, right? Here I'm going to select. So how many? So since I have connected with admin user, I can connect with how many users are available. So you can select star from users. So one of the table. Okay, so user tables. So all underscore users is one table. Okay, so it's showing like table or view does not exist, right? You will have the all underscore users. So when it has been created, it will show you. It's showing like DDMM YY format. So this is the latest user I have created, 4 user, right? So after that, all other users are system user only. It has been created 2014 itself when they have given the software, right? At that time, the HR user, the predefined user, which is available already in 11G software, 11G versions it is available. So these are all the user schema which is available. But in real-time project, you will not have access to this particular table. Okay, this definitely will not have access. And we have the system user, sys user, both are same. And we have the HR user and core user. Core user only we have created. Okay, when it has been created, what is the user ID, all this. These tables are dictionary tables. This is called metadata tables. If I'm going to create a new user, then Oracle will make an entry in this particular table. Okay, so that is what it will make an entry. And these are all the dictionary tables. Okay, you can ask me how many dictionary tables are available. So I will give you this particular list. See, in this particular list, we will use most of the tables. We'll use constraint tables, all underscore constraint underscore columns table, all underscore errors, indexes. So index columns and objects, sequences. Okay, so all underscore tables. See, lot of tables will be there. These are all the dictionary tables which is available in. So DBA users and all underscore user also is one of the table. So you will have it here, right? So information about all users of the database, all views. So these tables maintained by the database itself. So I will give you the list. You can have it. So just to go through one time. So going forward, we will use some tables here from here. Okay, so you can use it. So if I want to know how many sequences are there, so all this you can able to view by using this particular tables only. So these are all the dictionary tables, metadata tables. Okay. So where these tables will be available, these tables will be available in the system schema. So not with any other schema. So from other schema, you'll have only the different tables, but you can able to access. If I want to know this particular tables in real-time project, you have to ask your DBS only. But here, whatever the users we have, different user that you can able to access it. The other users. Okay. This is SQL develop SQL plus, right? So whatever you are seeing here, so that can be viewed from the SQL developer also. See, this is another tool. So how many records are there? 17 rows are selected. Okay, 17 unique users are available. So this is GUI, right? See here, everything is like a black color screen you're showing. It's not user friendly. So in order to give you like a user friendly data, SQL developer, the Oracle has developed with one tool called SQL developer. From this tool, you can able to connect with any schema. See here, this is admin schema. So in order to create this, you have to click on the plus symbol. So that means from here, you are creating the connections to the underlying database. To the underlying database, you have to tell the username, password, and host name, port number, and service ID or service name. So that you have to define. So if you are defining it, it will connect. So here I'm just going to connect with admin schema, system admin, just I'm connecting. Okay, this installation process, I will give you one video just to go through. By today, you have to have this particular SQL developer in your system. So if you are facing any issues, please let me know. I will guide you how to do this. So in the admin schema, the same query I'm going to execute. Select star from all underscore users, right? Yes, if I'm going to execute same 17 records, I can able to see here, right? All rows fetched 17. Same 17 record, I'm going to see this. So this is the same data I'm viewing here also, SQL plus, right? See, whatever the data here it is showing, that's fine. The front end tool, only the tool is different, but underlying the data is coming from the underlying database. This one database only. Clear? So you can use SQL developer, you can use Stored for Oracle, you can use DB visualizer. Is another tool. Okay, so any tool you can use. but underlying database is same. So in this particular database, if you take this tables, you can see all these tables are related some dollar symbol and all this, right? So these are all metadata tables. So who will maintain this? Can I delete these tables? No. If you are deleting it, your Oracle database will get collapsed. Okay. So these tables will be maintained by the Oracle itself. Whenever you are going to create a table or user or anything, it will make an entry here in this metadata tables. So in this, we are not going to do anything. Just to keep it as it is. Don't change it. Okay. So this is a tables, views, indexes, right? So you have this the sequences, synonyms. So all this you'll have different objects. Okay. In addition to this, you can create n number of user schema. So this is HR is one schema. So inside the HR, you'll be finding different objects, right? Here we have the tables, views, indexes, and PLSQL object like package, procedure, functions. So different triggers you'll have, and you'll have other users also. So you can see by using here HR schema, you will have other users. The same, how many users can have access to this particular schema? Okay, so you'll have anonymous user. So these users 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See, all other users have access it to this HR schema. So mostly these schemas are these users are from the same database. But for an example, the core schema, if I want to access it, these schema tables. Okay, so for an example, customer table here we have the HR schema, but I'm connecting to a core schema. If I want to access from here any other schema tables, then DBA need to provide it access. Select star from customer. Can I access it? If I have a table here, I can access it. HR schema tables, can I access it? See, I can able to access it, right? This schema tables. So how can I access this table? Why? Because I have given access already. So DBA access I have given. Granted DBA access to this particular core schema. So that is why from core, I can able to access HR schema tables. See HR. If I'm not going to use the schema name dot table name, it will go and check the tables in only in core schema. If I'm not using any other schema name, right? Simply I'm making customer. So where it will check customer table here only. If I'm going to use HR.customer, then it will go and check here. Here I have the table called customer, right? Yes, I have the table called customer. Then this particular data, it will show here. That's it. I have provided access to this course schema. That's why it is showing you the other schema, right? So that's what you can able to access the other schema. So whatever the other schemas are available, it will show you. So user, that is what user is nothing but in Oracle database. If you are creating a schema, it will create like a user. Okay. HR user, core user, all are user only. So don't get confused. These are all schema in the real-time project. So if you are going to a project in one particular schema, you have multiple users. They will be creating all the users. They will provide you the access to this particular user schema. That's it. So you can able to access it here. Schema is different. Database is different. Okay. So database is entire database is called database, right? This is database. Inside the database, we have 3 schema now. So who will create the schemas? As I told, only admin will create the other schema users. Okay. Can I create user from HR? Can I create it? Create user, username. So some user I'm going to create, some test2 user, just one user I'm going to create, identified by password. By password test2. So if I'm going to create, if I have given DB access to this particular user, then I can able to create it. But otherwise I will have error like insufficient privileges. But who can create? System admin can create? Yes. System admin can able to create it. See here, I have created one user, right? If you go and access now, 18 users will be available now. Right? 18 user. Test2. Just now I have created. 4th February 2023, I have created a test2. But I have to provide access. If I do not give access, if I'm not giving privileges, then this test2 user will not have access to create the tables. You can able to access it. So you can go to this one. Test2 is the one of the schema. So you can have the test2 here and test2 here, right? Test it. See, I do not have privileges. Lacks create session privileges. You remember? So the schema I have given here, right? Create session to core. This way I have to execute this particular grant permission. You have to execute. If I'm going to execute this particular permissions, for an example, these particular permissions, who will provide the permissions? Only the admin will provide. So now I'm going to create a session. Session means, so this is one session. So test2. I'm going to create a new schema. Is test2, test2. But if I'm going to test it, now testing it, right? But this test2 will have create table access. Create table. One table I'm going to create test table. So open bracket. Some list number data type. Okay. So can I create this? See, I have created a user, but I didn't provide the permission to create the tables. Got it? In this particular schema. Who will provide? I have to execute this permission. See here, this permission I have to execute. Then only grant create table. Then only this particular user will have access to create the tables. Okay, still I do not have permissions. Okay, so to create it, I do not have permissions in the system user. But you can go for DBA. So you will execute all these permissions it will have. Otherwise, you will have connect and resources. You can have one more. Grant, connect, comma, use resources to test2. So if you execute this permission, then test2 will have access to create the tables. See here. So test table has been created here, right? So who will provide all the access? Only admin will provide the access. So if you are giving grant DBA2, test2, all the permission we are accessing, we are delegating our permission, DBA permission to this test2, then test2 is like a DBA. Database administrator will have all the access. Got it now? How to create a new user schema. So now the test2 will have all the users and you can able to connect with, and you can go to the other schema. Other 17 users will be showing here. But if I want to access any other schema tables, can I access? So from here, I have accessed HR schema tables, right? From core schema, I have access to HR schema tables, right? Previously. Can I access the same way just HR schema tables from here? No, I didn't provide the access, right? I didn't provide the access. That's why. But if I'm going to give DBA permissions, grant DBA to test to connect the users, grant succeeded. So now I have given the grant permissions. Okay, so still I'm not able to connect with. So even the grant permission, this particular user also it is not having access. So you need to have different permissions. Grant DBA to this one, right? So that even this permission also not able to connect with. So you need to go for any other permissions that we have to check it in the. So what is the permission needed to access the tables? That permissions we have to provide. Clear? So this is what you can able to create multiple schemas. So this is one schema, this is another schema, this is another schema. So here I'm going to create some tables, test tables. See here, I'm going to create one tables, test tables. It is already available. Insert, just I'm going to do insert into test tables. I'm going to have values. Some values I'm going to have 30 or 20. So what is the value? You'll see it now here in the test tables. So 20. Can I have the same kind of tables here in core schema? Yes, same table can be created. Yes, here I'm going to create one table, test table. But in this test table, I'm going to show 30 here. Okay, remember one row inserted. If I'm going to execute, 30 only will be showing. Same test table only. I have created both the schema also, the schema also. But I can go to the admin. I can go to the admin. Can I view this table's data? Can I view? Select start from? No, you will not able to directly view. Then how can I view? HR.test tables, yes. Or where I have created core dot key and the test tables. And test2 dot, yes, why the data is not showing? See, we have created, right? We have created the tables, but why the data is not showing? See, in Oracle, if you are seeing this, the data is showing, right? 30. Which schema? Core schema, test tables. But why it is not showing here? Core schema. See, we have the session. Got it? So we have given the session. What is the session? We have taken one session here. In the session we have created. So you have to commit it. So you have to commit. So after committing it, that means you have opened one Word document, you have typed something and you have closed without saving it. The other user can be able to view? No, right? Same way here also. See here, now you can able to view. Clear? Core your view. Test2 you can able to view different date. So that is what the commit and different user, different sessions. Are you clear what is that? Multiple users. So who will give the permission, access and everything? Only DBS will take it. So we are not going to bother about the access and privileges, user IDs, all this. Okay. So as a developer, no need to bother. So if you are a DBS, then you have to bother about all the tables and views. So how many users are there here? System user, HR user, core user, test user. These are the 4 users are available. So other users also available. 18 different users are available. You can able to view all the 18 users. So these are all the users and schemas and everything. I hope you are clear now, right? So what is users? So what is schema and everything? So what is session also? Session we have taken and inside the session we have created the tables and that session also we have seen. So please first you have to install the database. First install it database. You can go for 21C or 18C or any databases. So after installing the database, you can have SQL developer or Toad for Oracle or any SQL tool, the front end tool. With that, create the connections just to access the tables. So HR is one of the user here. I hope you are clear. So if you want to go for more on how many users are there, who will provide access, all this, you have to check the dictionary tables only. Okay, so that we are not going to see it here. Just we are going to learn only the SQL queries. Okay. So we do have different data types in our Oracle database. So I will give you one particular document which has all the data types. Okay. So we have all the data types here. So if I'm going to give this particular reference, so it will have the data types here. So all the data types we have. If you go to this particular one, so we have the character data types. We have character, varchar, n varchar. See, n varchar means wherever you are having the n varchar, it is nothing but it is like Unicode characters. See, if you have some special characters, right? So if I want to keep, see, if I want to store these data into database, which data type you will use? Varchar data types. But sometimes you'll have Unicode characters. So Unicode characters, right? So you'll have Unicode characters. It is nothing but these are all some Unicode characters. If I want to have Unicode characters in my, see, you'll have some Unicode characters. These are all the Unicode characters. Okay. So some data you will be seeing this kind of data, right? So if I want to keep, say for an example, copyright, how will you keep this data? So plus or minus, right? So these data, if I want to store here, this will not take one single bytes. It will take 2 bytes actually. See here, this data, if I want to store, I cannot go with directly with A. See, it's one character. It will take 2 character types, right? So A and then you have one tilde symbol. So these are all the Unicode characters. If I want to store these data, you have to go for nchar or nvarchar or nvarchar2. Clear? So that's what you will go for nchar, nvarchar, all this. If I want to store Unicode characters, date, timestamp, all this we have, and the large objects and number data types and row ID. So different data types are there. So just go through this particular document. You'll get clear idea. But whatever the frequently used data types that I will give you so that you can get clear idea. So what are the different data types you have? So first you will go for numeric data type. Okay. So numeric data types, and you will have the character data type. And you will have date data type, and you'll have large object. So in terms of GB, it will store the data. So like the pictures, an audio file, video file, if I want to store, it will store in one particular field that is called a large object. So we do have 2 different large objects are available. We'll see one by one. So how to store the data. So you have the numeric data type, right? So mostly you'll have a lot of different data types. So, but you will use mostly like number data type. You'll have precision and scale. So precision and scale means precision is nothing but whole number and scale is nothing but the decimal point. So this number data type will hold all other data types. You can go for float, decimal, all this it will hold. So that's why we will use only number data type. And then character data type. So we used to have char. We can go for varchar. We can go for varchar2. Okay. Same way you can go for nchar, nvarchar, nvarchar2. So as I told, n is nothing but, so you can go for the Unicode characters. And date and time data types. Yes, you will have the simply a date and timestamp data type. And the large object you will have. So different large object. Okay. So binary large object and character large object will have. So these are all the different data types. So what is that? So you can have number alone. It will have predefined length based on the database version. It will have predefined length. So mostly 21 bytes it will go for maximum 21 bytes, the 21C database. So I will give you this particular document. You can refer this document up to which bytes it will take. Then you can go for number of P, S, precision and scale, and character. So character, it will go up to 2000 bytes. So you can mention 2000 bytes. So up to 2000 bytes you can go for. And varchar, yes, here also you can go for 2000 bytes. You can go for 4000 bytes. Okay, so 4000 bytes. In real-time project, we will use varchar only. So nowadays, the Oracle, they have deprecated this particular data types. They have deprecated this particular data type. It is not available now. And date, yes, whenever we are mentioning the date, so you have to provide the format. Okay, so mention that format. Whenever you are in input the date and time, so you have to provide the format. So default format is DD-MON-YY format. So this is the default format in Oracle database. But whenever you are giving any format, you can define the format. On large object, I will take later. So binary data, character data. So how can I store, say for an example, if I have the data in this format, if I want to store these data in the database, I'll go here. I will take one customer data. See here, this is what my customer data. So how can I load all this? If I want to create the tables, I have to go for data type first. This is my customer ID. Yes, I will have only numeric data. This will have characters. Yes, I can have the name of the customers, characters, mobile numbers. It depends. You want to add country code in the same mobile number, or you want to go for country code in different column. So that is different. Date and time, city, and email ID. Email ID will have numbers, characters, and special characters also, right? That's what you can have it. So data types are very, very important. So for this, you can go for number alone. Number alone. How many digit you want to go for? So that you can go for. Say for an example, you want to give number. So number alone. So you can provide just simply a number data type. So if you are taking this way, so if you take this way, number of 6 means maximum it can hold up to 6 digit. That's the meaning. Okay, remember. So you might be doing some mistake here. So make a note of it. If I'm using number of 6, you can go for up to maximum 6 digit. Number of 8, 2. So you can go for any whole digit up to 21 digit. So you can go for number of 8, 2, right? 8, 2 means, so remember 8, 2 is nothing but total digit is 8. Precision is 8. Total precision is 8. Out of 8, 2 are decimal scale. So you can go for 2 decimal point. Okay. If I'm going to mention number of 2, 2, how many up to which number I can store? See, most of them will say like number of 2, 2, we will assume that it will take up to 99.99. So remember, it will not store up to 99.99. It will store only 0.99. Why? So why? Because 2 decimal, so 2 precision, out of all the 2 precision are scale. That means 0.99 only. If I want to store 99.99, so what is the data type you have to provide? Number of 4, 2. So that means 4 whole digit. Out of this, 2 digits are decimal point. That's the meaning. Clear? And character. So character, it will go for 2000 bytes. So nowadays we do not have this character varchar, variable length characters. So this is not available. It is deprecated. Even if you are going to mention that varchar, it will take it like varchar 2 only. So varchar 2, you can go for 4000 bytes. Then what is the difference between all the threes? Okay. So if you are defining like varchar, so it will take null spaces also. In the memory, it will take null spaces also. Okay. So if you are defining varchar, it will take varchar 2. So that means it will go only with, so whatever the length you are giving the data, that particular length only it will occupy in the memory. Okay. So I will show you that details so that you will get clear idea what is that. If I'm going to create one table, I'm going to create one table called test table in the HR schema or test one table. You can take whatever you are seeing in the blue color, the databases, it is a keyword. So that name, don't give it for table name. That's why I'm giving like test one. Customer ID, I'm giving like number of 2, 2. Okay. So I will go for one more customer 4, 2. Customer ID, I cannot give one more. It will show like same IDs are available. I will go for customer number. Customer name, I'm giving character of 10. Customer name 2, I'm giving varchar of 10. What is the difference? I'll execute. Test one table has been created. I'm going to insert the data. So I will insert the data. Insert statement we'll see after. But I'm just inserting the data. Insert into test one. I can go with the values. So 2, 2. So 2, 2. Can I go with 1? It will not take. That's why it will give you the error. Customer number. Can I take 10? Yes, you can take 10. And customer name I'm going to give. So what is the name I'm going to give? See, whatever the varchar you are going to give. So varchar data type you give like single quotes. So remember, for any varchar or character, you give single quotes. Then I can go for the same way customer name 2. So name 2, I'm going for name 2 here. It's 5 characters. If I'm going to execute, will it be executed? No, I will get error. So why I'm getting this error? Value larger than specified precision allowed for this particular column, but it will not show you which column it is, right? It will not show you. You have created table yesterday. You are going to insert the data. How can I know this which column it is? You have to describe the table, DSC table name. Just to describe it, it will show you this, the precision and scale. See here. So as I told, if you are going to give 2, 2, up to which number it can accept? Up to 0.99 only it will accept. So can I go with 89? Yes, it will accept it. So now it will accept. Can I give 100 here? Can I give 100? No, I cannot give 100. So again, you will get error. So why? It will accept only up to 10. Okay. Yes, I'm going to take this one. See here, one row got created. So have you noticed here? So what is the data type here I have given? Customer name to while creating the table. I have given varchar, right? But how Oracle has taken? Oracle has taken as varchar 2. What is the maximum I can go with? Varchar 2. I can go with the maximum 4,000 bytes. Up to 4,000 bytes you can mention. Character, how many bytes you can mention? 2,000 bytes. Then what is the difference if I mention 2,000 here, 4,000 here? See, if you mention 2,000 for any characters, it will allocate all the 2,000 characters. Out of 2,000 characters, the customer name, how many characters I'm giving? Arun, 4 characters. Remaining all the characters, right? 1996 characters, it will be reserved in the memory. For an example, this scenario, I have given character of 10. How many characters I have given? 4 characters. That means remaining 6 characters, it will be reserved. You can see here. Just one, right? Just one. 0.89 is stored. And it has been stored. And Arun has been stored. Kumar has been stored. But what is the difference between these two? If you open this, you can find right hand side some null spaces, right? You're seeing some null spaces, right? So you're seeing some null spaces. How many characters? For every record, it will allocate 10 spaces. If you are not providing 10 spaces, the remaining character, it will take it like null spaces. For one record, it is taking 6 bytes. If you have millions of record, how many memory bytes it will be wasted in the memory, right? So in order to use the memory in an optimized way, you have to go for varchar2 data types. Clear? If you check the length of this first name, LENGTH, length of customer name, it will give you customer name too. So first one, still it will give you 10 only. So even though you have 4-digit characters, still it is taking 10 digit. But varchar2, how many characters it is taking? Only 5. Even though you are going to mention 4000, no worries. So that is why you can go with varchar. Clear? Any doubts? So what is the difference between varchar and char and varchar2? So nowadays we do not have any varchar. Even though if you are going to mention varchar, it will take it like varchar2 only. And character, it will occupy the null space. And what is the difference between number data type? Number of p, s. Are you clear on this data types? Any doubts here? Okay. So in customer name, we have mentioned 2000 bytes. After executing the statement, I have mentioned here. Have you noticed clearly? Have you noticed? I haven't executed the statement, right? So when I have executed, I have mentioned only this. That is what you have to describe the table. See how much I have executed. Only with 10 characters only, right? After executing to show you that I have changed it here. That's it. But I haven't executed the statement. You remember? While executing, I have mentioned like 10. I have mentioned 10 here. After that, I have mentioned that you can go up to 2000 bytes. Got it? So what will be the case when character will be used? Yes, character normally we will not use on our real-time project. So if you know the definite length, okay, customer, something like the customer country code. So country code you'll have only 2 digit you are going to have. So that you can have it like character of 2. So you can mention. So that means IN India, US, USA, UK. So only you are going to mention with 2 characters. Yes, you can mention with character of 2. So even instead of character, you can go for varchar of varchar2 of 4000 also, no issues. Okay, even if you are going to use 4000, how many characters you are going to in the runtime? So that is the memory space it will allocate. Clear? So that's what we have to use varchar data type. So if you go to real-time project, definitely we will use only with varchar2 data type, only with number data type and date data type. And large object, if I go to large object, we will use large object data type. That we will see it later. I hope you are clear on this. So just to create the tables, just to check it with basic. I will give you some exercises today. Then I can able to access it. I hope you are clear on the data types. If you want to go beyond the data types, I will give you some data types here. This particular document, this is the latest document for 21C. You can go to the data types here and check it how many different data types as we have. Okay. So you can go down and then different data types we have. So varchar2 is from 1 byte to maximum 4000 bytes you can use. If you are using one keyword like maximum string size is equal to extended, then you can use up to here this much type. Okay. So processing times will not change. So n varchar, yes, if I have the UTF-8 characters encoding, then you can go for n varchar here. So variable length Unicode character. That's what meaning of n varchar. Okay. So no need to get confused more on this. Just to leave it. So precision and scale. So you can go up to 38 digit. You can go with. So number, you can go requires from 1 to 22 bytes. It's for Oracle 21C data type, 21C database version. So if you are using 11G, so it may not take this much byte. Okay, so based on that, you have to take that data types. Okay, precision and scale, please watch it one more time. The recording I will provide it to you. So you watch it. So I have explained, right? So what is that precision and scale and all this? So just to watch it one more time, that's why I have asked you to note it down whenever I'm explaining. I will give you the recording. So please go through it. So if you take precision and scale, so precision is nothing but whole digit. Scale is nothing but the decimal point. That's it. If you are not going to mention precision and scale, it will take only whole digit. Okay, clear? Yes. See that in SQL, okay, in Oracle database, the SQL can be classified into 5 different types. So if you know these types very clearly, then SQL is very, very easy. So SQL can be classified into 5 different languages in Oracle database. So what is it? First one is data definition language. Okay, data definition language. It is a DDL. So we will call it as DDL. So you have to practice 1 or 2 times. Then you will get to know all this very clearly. So first a few days, it will get confused. What is DDL? What is DML? All this. But if you are practicing it, it will get memorized. See, DDL is nothing but data definition language. DML is nothing but data manipulation language. DRL is nothing but data retrieval language. TCL is nothing but transaction control language and data control language. So what is it? See, if you are a DBA, mostly you will have access to this DCL. If you are a developer, you will not have access to this DCL language. So DCL is only for DBS, okay, database administrator. They will grant a permission, they will revoke a permission. So, but in real-time project, we will not have access. So what is transaction in database? See, transaction is nothing but if you go to this particular table, this is insertion is one transaction. If I'm going to update this particular with phone number with some other data, it is update is one transaction. If I'm going to delete this particular record, is called one transaction. Okay. So transaction is nothing but we are doing some changes in the database. So that is called a transactions. Okay. In the database, for an example, the database in the Excel sheet, I have deleted the data, right? But I did the control Z. So what happened? Control digits, it is nothing but the undo operations. It restore the data in the Excel sheet. The same way we can do it here in the database. So that is called, the undo operation is called rollback. Okay, the undo operations in the Word document or Excel sheet document, the undo operation is called rollback. Commit is nothing but after save this. So you are going to save this control S. After saving this, you cannot do the control Z, right? After save this, can you do the control Z? No, I'm not getting the control Z. See, you have deleted. Then you have saved it. Control Z. After that, can you do the control is? No, we cannot do it. See, after control yes, you cannot roll back it here. The same way in database, after commit it, you cannot roll back it. Commit means you are going to save the data permanently in the database. So that means in Oracle, we'll have the file system, right? So it will go on permanently right in the files and then it will commit it. So that is why after committing, you cannot roll back it. So what is data definition language? So data definition is nothing but it deals with structure of the table. Okay. I want to have my customer database. I want to have my customer data in one particular table. So customer ID, customer name, mobile number, date of birth, city, gender, all the details I will collect from my customer, right? See how many columns I want to collect, how many data I want to collect, that I will define it. I will keep it here. Okay, I want to have one more column. So here, how many columns? First I'm assuming that, okay, 6 columns is enough. So these 6 details is enough. After some times, I want to go for some more columns here. So first I'm going to define a structure of the tables. So this is called creating a table. How many columns? 6 columns. Just to create this table with 6 columns. Yes. After that, insert the data inside it. Yes, you are inserting 2 data. So that is called insert. So insert is DML operation, data manipulation language. Yes, you are inserting, you are deleting this record, you are updating this record. So this insert, update, delete, these all operations are call it as DML operations. Insert, update, delete, and merge. Merge concept I will show you is nothing but, so you take data from one table and you merge it to another table. So that is called a merge table that I will tell you later. So insertion, updation or deletion or merge, these 4 operations are DML operations. Create table is nothing but you are creating the table. Okay, insert the data. So after some time, I'm thinking that, okay, I need to get the marital status and gender of the each and every customers. Okay, I will add one more column. Gender, yes. Marital status. So I will take one more column here, right? And these are all the columns if I'm going to add it in the existing table. That means I'm altering the structure of the table. Yes. So I'm altering the structure of the table. So adding a column. So whenever you are adding a column, you can add at the end only, not in between. Okay, I cannot add here. In between, I cannot add it here. I can add always at the end only in any databases. You can add it here, alter the table. You can add a column, or if you do not want a particular column, you can right click, you can delete the entire column. I can delete it, right? So this is nothing but drop a column. Okay, so drop a column. You can do it by using alter and rename. Yes, you can rename this column. You can rename the table name. I can go for customer data. Yes, you can rename the table. You can rename the date, this particular column, this particular column. These are all renaming a table. And truncate. So truncate is nothing but, so you have billions of data in the table. You are just erasing all the data, irrespective of number of record. You are truncating all the data. It is called a truncate. Okay. You are dropping the table. Drop means, see, if you are truncating the table, only data will get truncated. The structure will be maintained. Okay. If you are dropping the table, so structure and data, everything will get dropped. So everything will get dropped. That's it. That is what a truncate. But these truncation, deletion, all this we will see later. Whenever you are executing DDL statement, so up to that particular statement, it will get committed. So that means we are executing control S. So you remember, it will get auto commit. Okay. Whenever you execute DDL statement in Oracle, it will get committed. Whenever you have executed DML statement, you have to commit it. So you have to commit it. Okay. These details we will see very clearly in our tomorrow session. First, I will create the table. I will insert some data. Okay. So that you can practice today. See here in Excel sheet, I can do the control Z, right? For saving it, I can do the control Z. But in database, whenever you are going to execute this TDL, you cannot do rollback. Why? Why? Because it will get auto committed. It will automatically save up to that point. Clear? Okay. So if it is confusing you, don't worry. We are going to see one by one each statement so that you will get clearly. I want to create this particular table. So how can I create this particular table? So that I will go with. I have to create this particular table. It's very simple. So I have to go with create table statement. So what is this create table statement? So this is the create table statement. How can I create a table? So you can go with create table statements to use create table. This is a syntax. Okay, remember this. This is Oracle syntax. Most probably, most of the database you will have the same syntax. Create table, table name. So you'll have the whatever the table name you want to provide. Just you have to mention the table name. Create table, table name, open brackets, and so this type you just to practice it. Okay, column name. You can go for column one, and their data type. If you are giving any space, so Oracle will consider next one is data type. If you give next space, Oracle will consider as constraints. So you can have n number of columns, no issues. N number of columns here, column 2, column 3, column 4. So this way you can have n number of columns. Then up to you can have the column n. You can have n number of columns. So remember, finally you should not use comma. If you are making comma, Oracle will think that okay, you are going to give one more column. So don't use comma. So just close whatever you have opened here and semicolon. So what is the use of semicolon, right? If you make semicolon, so Oracle will think that the statement has ended here. Okay. So from this semicolon, last semicolon to this semicolon, one statement. So that is what it will execute. So in the real-time project, if whenever you are going to give a multiple SQL statement, so Oracle will interpret in that way only. So this is the way you have to create the tables. Then how can I create the table for this particular scenario? So you'll have all the columns, right? You take all the columns. Just to go here, just to create table name. I want to create a table customer. Open bracket. Then I can have the column names, right? So I can have the column names here. So you can do it one by one. First, I will do here like this. And customer ID. See, mention the column name with the underscore. Don't use customer ID like this. Okay, don't use like this. So if you are using like this, how Oracle will assume that this will be taken as column name. This will be taken as data type. Do we have any data type called ID? No, right? So that's what you will get error. So you will get error like this. Some underlying the line if you're showing that is called some error. It's happening. Okay, so customer ID, it is nothing but number data type. So you can mention how many numbers you will go for, maximum 6 numbers, 7 numbers, 8 numbers. Yes, you can go for 8 digit. You can mention that number of 8. Customer ID will have precision of, will have the scale from decimal point. No, right? So that's why I'm not using any scale here. I'm not using any comma here. Okay. Customer name. So customer name will have character data type, right? Which data type I can go for? Varchar2. How many maximum I can go with? 4,000. No need to go for 4,000. You can mention like 1,000 characters or 100 characters. That's fine. Then make the comma here. Mobile. It's a number of 10 digit. Yes. Comma. Then date of birth. Simply use date. See, while creating the table, you have to use date data type. While inserting the data, you have to provide the format. So create table. City. So what is the data type? You can go for varchar2 of some 30. Right? Then email ID also. So email ID, you can go for 100 characters, right? You can use 100 characters. No issues. Just you can use the same. So what is the error here? So it is showing clearly that, so error is here, right? It's making underline here. So that means some error is happening. What is the error here? I'm using one comma. So if I'm using one comma here, so it will show like missing expression. Okay. So invalid identifier or missing expressions, or you are using some expression here, it will show like missing expressions, right? Parenthesis, all this it will showing. So that means you have to use So right parenthesis means missing right parenthesis means you have to use some comma here. You are missing here. Since I'm using comma here, it is expecting one more column. That's why it is showing like invalid identifier. Say identifier means column name. In Oracle, if you are getting any error like invalid identifier, how will you identify? Invalid identifier is nothing but column name is wrong. So remove that semicolon. Just execute this particular statement. Okay, I'm getting some error. So what is error? It is showing like name is already used by an existing object. So why? Why? Because in one particular schema, I can have only one table name with customer. Can I have one more table name with customer? No, it is not possible. So why? Why? Because here I have all underscore tables. In the tables, Oracle will maintain an HR schema customer as the one of the attribute. Okay, one table name is one of the attribute. It will have a primary key. It will not allow the same value. So you cannot have the same table name within the same schema, right? So you can have one more table, customer one, that is fine. But same name, it will not allow. Okay, that's why you are getting the error. So for that, what I'm going to do, so this table, whatever the table which has, I'm going to drop it. Drop table name. That means existing customer table will get dropped. How can I execute this particular statement? See, always you can use the semicolon. Keep the cursor anywhere in the particular line. Okay, anywhere in the particular line. Anywhere you can keep it, no issues. So you can keep inside, you can keep outside, anywhere you can keep it. Control enter. That means this particular line alone will be executed. So from this semicolon to this semicolon, it will get executed. If you don't use the semicolon, it will show you error. So here, if I'm going to execute, it will show you the error. Okay, missing or invalid options, right? So that means the entire statement, it will take it like one single statement. That's why you have to use semicolon here, then keep the cursor anywhere. So just I have executed, existing table will get dropped. Since one more time I have executed, I'm getting this error. Table or view does not exist, right? Okay, no issue. So you can remove this. Assume that. So this is the very first time I'm going to create the table customer. So keep cursor anywhere in the syntax. Just control enter. One table has been created, right? Table has been created. Assume that today you have created. So tomorrow you are logging into the database. Create table is DDL or DML. Create table is DDL or DML. It is a DDL. Okay, DDL is nothing but data definition language. So creating a structure always is a DDL statement. Do I need to commit it? No need to commit. So that means even if you are closing the session, this table will have permanently in the database. Okay. So I have to add some data. So you have to check how the table has been created. You can use describe the table. So you can describe customer ID, customer name, mobile number, date of birth, city, email ID. All this you are able to see here, right? Then what is this null? I will tell you. Okay, nullable or not nullable. While taking that constraint, I will show you. As of now, null. So that means it will accept null value. Okay, it will accept null value. On the null value means nothing. It's a blank. Okay, I have to insert the data into the table. So you have to go with insert statement. Insert into table name. Okay, insert into table name. You can mention all the column names in the brackets. Like you can mention the customer ID is comma, then customer name, comma, then mobile, comma, then date of birth, comma, then you'll use city, comma, then email ID. So you may ask question whether column names are case sensitive or case insensitive. These column names are case insensitive. You can have it like table name or column names, any cases, lowercase, uppercase. This statement also. So you can have any cases, but in Oracle, datas are case sensitive. So remember, datas are case sensitive. Then you have to insert the values, right? You have to use values. Okay. Customer ID, corresponding values you have to do. So where is the corresponding values? This is the value, right? So copy this value. Just I'm copying it. If you want, you can make it like one by one. So you keep here customer ID, yes, 1 comma. Then customer name. Customer name you have to put single quotes, right? So it's a varchar single quotes. Then number. Do I need to number data type? Do I need to put single quotes? No need. Like this. Then what about this data type? So in order to insert the data type, you remember any front end tool if you are going with, they'll be mentioning like, okay, DDYY, all the data type, right? So that's why here also you have to mention that. You have to mention to_date. So which date we are going to mention? 06 19 90 single quotes, or you can mention any other 1998 or something. You can use single quotes. You have to use here. See, whenever you are giving data type, always make sure that you are using to_date while inserting the data. So to_date within single quotes date, comma, within single quotes, you have to mention the same way you have to mention the format. That means we are informing Oracle that this is the format we are going to give. Okay. So this is DDYYI format, then comma here. Then Hyderabad, I have to put single quotes, right? Yes. Put single quotes here, semicolon. Then I have to put single quotes again. So here also single quotes, close it, semicolon. That's it. You can execute this particular line. See here, entire one, you can execute one row, got inserted. Then you can check whether the data has been loaded here. Yes, you can go for select star from customer table. You can insert one row had inserted. Yes, very clearly inserted. See, after inserting it, I want to insert one more record. You can go for one more insert statement. This time I'm not using column. This column names I'm not using. I can directly go with another record. The second one, customer ID, the customer name, and the mobile number, right? So mobile number and date of birth. I can use date of birth here. I can use the city here. And I can use the mail ID here. So I can execute this. Here also one row got executed. Then you may ask question, what is the difference between these two statements, right? So here we are mentioning the column names. Here we are not mentioning the column names. If you are not mentioning the column names, how many columns are there in the table? So 1, 2, 3, 4, 5, 6, 6 columns are there in the table. Same 6 column values you have to define in the same order. Okay. Customer ID, yes. Customer name, yes. Mobile number, yes. Same way. But if you are mentioning the column names, if you are mentioning the column names, if I'm going to one more time, if I'm going to mention the column names without date of birth column or without city column, I do not know what is the city as of now. Just I'm mentioning only 1, 2, 3, 4, 5. Then you can mention only 5 columns, right? So 1, so I can go for some other details here, mobile numbers and date of birth. So I can go for date of birth here and directly email ID. Yes, no need to mention the city here. So that is the advantage. Okay. So that is the advantage. You can use it here. So you can execute this particular line. It will get executed. Then what about the what about the city for this particular customer, for the John? will be taken as null value. So why? Because we haven't provided, right? So that's what it will take null. Null means nothing. So that's the difference between these two statements. So if you are mentioning without column names, you have to mention all the columns with same order. But mentioning the column names here, you can skip the columns, but you can change the order of the column also. Not an issue. Okay, how many records are there in the table? 3 records are there in the table, right? So what I'm going to do, I'm going to roll back. I'm just executing the rollback statement. What will happen? It will be rolled back up to last commit point. Whether I have committed anything? No, I haven't committed, right? But create table, it will be auto commit, right? So create table, it will be auto commit. So up to this create table, only table structure will be available. These 3 statements will get rolled back. If you go and check here, everything will be there in the table. Okay, you have to run one more time. One row inserted, one row inserted, one row inserted. See, I'm keeping the cursor here. I'm just executing control enter. Now I'm going to check it here. 3 datas are available. Yes, I'm going to commit it. After committed, if you are going to see this, data will be available. If you are going to roll back, it will not be rolled back. It will show like rolled back, but it will be rolled back up to last commit point only. Data is available, even though I have rolled back. Clear? So today's exercise, I will give you some exercise on creating the table, inserting the data alone. So just to follow the same statement, just to create the table, practice more and more. See, these statements looking like very simple, but if you are practicing it, you will get the speed. Okay, you have to practice more and more. You will get more speed. And so the query wise, you can able to see in a very faster way. So tomorrow we will continue with this other statement. If it is getting confused with the truncate, drop, delete, all this, tomorrow we will see very clearly. So as of now, we have seen only create table, insert statement. Create table is nothing but DDL. Insert statement is nothing but DML. And we have seen the commit and rollback, right? And select statement also, just we have selected the date. So we will stop it here. So rest I will take it tomorrow. We will continue with the same table tomorrow. Okay. So if you have any questions now, you can ask me. What is the difference between schema and user? Okay, so multiple times I have explained. So please watch the recording. Schema and user same, right? See, that is what I have explained here. A schema allows you to logically group the object in Oracle database. A schema is created in Oracle whenever a user is created. If you are going to create a user, in that particular username, a schema will be created. Can we delete a schema? Yes, we can delete a schema. Who will delete? Only the admin will delete the schema. So we are not going to delete any user. So drop user username, it will get deleted. So if you go to the admin, you are seeing the how many users are there. You can see this select star from all underscore users, right? So you are seeing the test2. So can I delete it? Yes, admin can delete it. Drop username. Okay. Okay, I have connected here, right? So that's why you can disconnect it. The session will get over. Then you can go to the admin. You can control enter. Okay, so some tables we have the cascade operations that we have to do it. Okay, so drop user will drop the users only. So this way we will drop the users from the database. But as a developer, don't bother. We are not going to do all this. Schema is nothing but a logically grouped objects. User is nothing but for this schema, lot of users will be assigned. So as a developer, we are one of the user for this particular schema. But whenever in Oracle database, if I'm going to create a user, it will create a schema only.